something. So what I'm going to do today, we will kind of review quickly of what we did last week and continue. We kind of finish with the data. Let me just go to regression. Here we go. And yeah, this is for one, and that's for the multiple. Just to remind you, we kind of choosing a, I'm using my computer so I can show you the code itself, but it works exactly the same on the server, okay? And so here I can choose a country. We added the Uganda, if you remember. And if I click run train, okay, we'll see the data in a second. I will clean it up in a second. Let me just go into, let's just close this one and open the, let's see why I'm getting an error. We'll fix it. Okay, so let's see. Run it again. And bingo. Let's see. I'm getting an error. Let's see why. It was working last week. I probably have done some change. This one, where is that coming from? I did some change here and then just now where. Well, what I will do, I will open another project. It should work. So I don't have to spend your time on it. Should work from here. Should be okay. Yeah, it's fine. Okay. Okay, very good. So we'll go over this one and follow up. Beautiful. We'll work on this one today, okay? It's the same project, just one. You know, this is something where, you know, since it's already happened, so I can share with you. When you're developing a project, you really have, in every project, it's the one that you're developing on it, the one you're testing. After you finish, you move the whole things to another environment, you test it, and only after the whole thing is working perfectly, you upload it to the server, and which is on the internet, okay? So the one that I'm using now, it's on the testing, which I know it's working fine because I used it before. So let's get into here to machine learning project. And in the machine projects, we have several of them. And the one we want, I think it's this one. Yeah. Let's fold in. How are you guys doing on studying Python? You know, the beautiful things here, it's really getting much easier. Anyway, let's get into here. I always remind you, I think it's a good thing for you to. We did this object. We said that this project is the communication. So when I click on train, I try really clicking on train WB. This is really what I'm doing here. How can you tell? You can see here the number. I usually keep the number here, 9019. So you can see that I'm in the right function. Okay. And then I'm just viewing also this information. This is really the dictionary coming from the JavaScript. So I know I'm in the right place. I'm getting the data. I'm asking the data for Uganda, UGA. Then it starts working. The first thing it does, as we said, is building up this AI object. And we will go into that a lot, and I will enhance it in the next projects and will make it more sophisticated as we progress. For now, this is already nice one because it already has some structure. The WB analysis, it's this object. And you can see we have several functions that will repeat themselves as we go along. One thing we talked about, it was get data. And we went over that last time. I'll go over it one more time. You can see we have all these parameters we're checking, blah, blah, blah. And then we have this function get model. We went over that last time. I'll go over it again in a second. But I would like to go over the get data first. Okay. Get data. How is the get data coming from? Remind you that what we do here in the communication, I call this as a communication to JavaScript from Python. That's object. In all our projects, we always have a project and objects like this one. And the one that we're going to use is we're running train WP and we're creating this object. So when we create this object, the function in this object that is activating when you create the object, as we said last time, it's really the init function. That you should know in Python. Okay, so we're getting all those parameters and all of that, and then we do the get model. I will come back to that because this is happening before even getting the data. Okay, usually you'll keep it in this one, in the init. When you create that object, one thing is you create that model, and that model is ready to be operated. It's not doing anything after you call it. And later on, you will call the data, you get the data, and you feed the data into the model. Okay? That's usually the order that you will do in AI. But usually this function will be in the constructor of this AI object. I can even call it AI object. And sometimes that object will have even several other objects that you will call them to assist you. Even the data, sometimes you make even a special object just to deal with the data. This one, relatively, the data is simple. So you're not going to make a special object for that. Okay? Since we talked about it, this one, we talked about min-max scaling. It has to do with preparing the data. I'm going to get back to that. We talked about the get model, which I'm also going to repeat myself in a second. Eventually, the get data going to populate those two objects or those reference, you can call them. But that's really holding the data. One is for the training of the data, training the model, so we have data for the train and data for the testing. You memorize it. Honestly, it's repeating itself. You will see, we'll do it many times. But the function that you already called the get data usually will come when you activate the training function. This object, the AI objects, almost always will have a train function, which we can find here. We have the train function, you can tell here, okay? It will train the data. Now, will this one will do the training? Not necessarily, okay? But you can tell this train before it's being activated, it really does go and call the get data function. You can tell here. So this is an order, you will master it as you go along. But who is activating this function? Remember the process. We're starting by clicking on this function. We'll get back to all of that. We click on run train. It goes to Python. We have the objects in Python. And that object is calling the Python, this object, train WP. After this one is being called, it's generating this object. We're going to even have some space here. It's creating this object. So we have this WPA, I call it World Bank analysis. So you're calling this one. This one, in fact, as I said before, I repeat myself many times, which is worth it. This one, when it's created, it's really calling this function, the init. And the init preparing everything, preparing even the model that I'm going to utilize, and eventually, okay, getting everything ready. Then when I call the function, then after I create this object, I'm calling the function train. Now this function train, I'm transferring a lot of data to it, so it knows what to do. So this is why you have a dictionary here, which is basically is really transferring the country, transferring which data I wanted to pick. All of those I'm transferring to the object analysis. So this object analysis in his train function, which is here, get all this information and start working. First things it does, pay attention, call the get data. You always will have this kind of function, get data, stage number one. We're getting the data, we're preparing it, we normalize it. We went over all of that last time, okay? So here we go, let's look at this function, get data, which is right here. Get data. Now let's look at what the get data does. So stage number one is really fetching the data from the World Bank. And here as a system, we have like a function that does all the work. I give it the country, tell him which indicator is returning a data frame. Okay, please go over last time what we did. We went over this function. I won't go over that again. But the bottom line is this function pulling data from the World Bank. Remind you, the World Bank already have given us a special library called WB data and has a special function. And this one is really doing all the work, okay? So really this function is a very simple one, okay? Basically, it's really utilizing the API of the World Bank. API, it means an interface, I can call it, give me the data. So I'm getting the data from the World Bank, and I'm getting data frame. Last time we saw and we looked at it. Here I point it again. Point data frame. And you know what? Let's do again. That's stage number one in the data. Let's call it A data. Let's call it that way. So here we go. I'm pulling it from, and I will look at the data. This is the raw data I'm getting from the World Bank. Stage number two, okay? I'm starting cleaning and organizing. Stage number two, we're taking this data and we converting them to a NumPy. In fact, when you call values, it's transferring data frame into a NumPy array, which is like a table with no headers or no columns names and all of that. And we're getting the X, all the indicators in this one, and this one is the variable we try to explain. If you remember, this Y is the GDP. Okay, so let's print it so you can see it. We'll do it again. I will just add the word data here so you can see data, so we know this is the stage of data. Fair enough? Then next stage, after I get it, I'm converting. It's really just technical. It's programming because I use NumPy array for models. It won't take data frame. Okay, but data frame, it's a special object, which is beautiful to manipulate data. So usually you do a lot of work on the data frame, but eventually when you need it for the model, you convert it. Secondly, we have a function called train test split. This is given in Python. It takes the data. We have those two arrays. This has 4 variables. This one has 1 variable. And we're telling him, split the data. What does it mean? Go make X and Y for training the model, and then you'll have X and Y to test the model. Always remember that we'll make clearer as we go along. I didn't cover too much time on that. And there were several questions, beautiful question. How do I split? Do I split 20%, 80%? common 20%, but we'll go into much more sophisticated technique called crossover or cross validation, and all of that will come. Can't really learn everything in one day. So there is a function, special function in Python that I tell him, go please split these x and y. The x has 4 variables, the y has 1 variable, split it. How do I want you to split it? 20% for the test, and you see test size, 20% of the data, and 80% for the training. So he's really giving me X training, which will be 80%, X test, 20%. Same things he does for the Y. And he gave me Y, 80% of the data, and 20%. This is really splitting the data. So if you can think about it now, we really have 4 tables, kind of. One that has 4 variables with for the training and 4 variables for the test. One, we have 1 variable, which is the GDP for the training, and Y for the testing. Okay, so here we go. We can print them here. This is for the train. This is for the data. You'll see it's very similar in the structure. I'll call it data again. Okay, and data. Fair enough. So now we got this. We know that we split it. This is the second number. We still really, this one is kind of preparation. As I said, we're kind of preparing. Normally, I will not do it this way, okay? Because, you know what I do? I take it back, okay? But I will think twice if this one will come before this or this one before this. For now, it's not that crucial. We'll come back to that, okay? Step number 2 is normalization. Okay, let's call this as a B for data. Okay, we have the data. You know, one thing that happened in the data, GDP will be a lot of big numbers. And we want to normalize all the data. So GDP, export, and education, the prices are different scales. So one thing we want to do is scale the data. We call it normalization. And we usually put it in a separate function. You see, this function is a separate function. We're transferring all those 4, and we're normalizing the data. So let's go back to this function, or jump to that, as we had this fetch. I will go over that one again, because this one, you're probably not used to it. I get 4 tables, as you remember, as I just said. We do a scaling. There's another beautiful, this one, if you remember, this object we created in the init. Okay, you'll get used to it. It's repeating itself. This is a special object. Takes a column, look at the highest number in the column, the lowest number in the column. Then it takes the lowest one is turning it to be the 0, the highest one to be 1. And then all the numbers in between, it turning them between 0 to 1. That's what this object does. It's called min-max scalar. The beauty here, it's an object that Python has created. And then you can just go ahead and use it, okay? Which is really nice, okay? So we created it. This object is already created. I'm just going to use it now in the get data, which calling the normalization. This order repeating itself, you will see when we get to the other projects. Maybe we'll organize them a little different, but basically it's repeating itself. Normalization is basically convert the data for analysis. Usually you normalize between 0 to 1 most of the time. Not always you use this min-max. Sometimes you use a normal distribution. We developed just recently a special min-max, but works totally different, okay? And much more sophisticated to get better results. But the idea is let's scale the data. So by the way, I remind you, the beauty here that this object min-max is also an object in Python that created as AI object. In an AI, as we will see with the model, we will use the function fit and transform. Okay, and sometimes you will do fit and predict. But in this case, the fit, what the fit does is actually going to the data that I'm transferring the trend, then in the fit section, it has two sections inside this function. In the fit part, is looking at the min and the max and knows how to scale it. And the transfer, it actually takes the data and convert them. So there is really two functions inside this function. The transform, the fit, and the transfer. After I do that, the scalar, you already know the min and the max. You keep it inside. You already transferred the data, so the trend X is converted to 0 to 1. The same things we do for the Y, the same idea, but we apply it. I won't get into that one. That I will spend some other time to explain to you why do you need to do the reshape. Let's keep it for now. Too much for one time. Okay, we'll get to that. That's a little hard concept, but we'll get to that. It's just converting to be a column the right way. Okay, but basically, I'm using this scalar and I'm filling the data and transforming the data. The beauty part, and I told you last time, many people make mistake. They do the same things for the test, and that's a mistake. You really should use the same object and do only transform, because the fit, it takes the min and the max from the training object data. And when he is applying it to the test, is taking this min and the max. They are the zero. Now, if I was making you a test or exam, and I will tell you, does this test X can have numbers below 0 and above 1? The answer is yes. Keep it as a question for home, okay? Keep it as a question for yourself to answer. I give you the answer, just trying to understand why. I give you a hint, because we are feeding the data with the data from the trend, but we only do the transformation. We're using the min and the max from this one. That's why you might get numbers above 1, but not really much more than 1, okay? And as we go along, I will spend more time and we dive into, okay, into deeper why people do it this way and why this is the right way to do it. Sometimes we do for the why. So this is the data normalization. The actual normalization is done really here. Some people call it as a transformation. I like to call it normalization. It's a much more professional name. So this function, normalizing the data, and we're getting the data, but pay attention. When I'm returning the trend X, I'm putting it as a tuple. It becomes to be as a one object that has two parts in it, because I'm most likely going to use it that way. And that's a good practice as well. You will see as we go along. That's a good one to get it back from the normalization stage. Okay, beautiful. So we got the normalization. And as you can tell, this trend data has two parts. It has the X and the Y. The test data also has as a tuple, has the X and the Y, and we're going to use it that way. Fair enough. Next, we have this stage number 3 here we did. I won't dive too much. I will get you more confused. This is the hard stuff, okay? This is really, I will kind of skip. The only things I said that we're doing here, we're taking this data, which has like about 40 or something like the 40, 50 rows for every year. We have data for Uganda, and we saw it last time. And we take blocks, because usually when you train the algorithm, it like it's in blocks. And now that's another topic. As we dive in the future, I will talk about how the algorithm actually finding the right answers. And that's, you need a little mathematics, and I don't want to dive into that today, okay? But basically, it takes the table, think about the table, and it split it to, in this case, to 2. Take 32 rows, and the remaining in the other table. So it has a table of 32 rows, and it has a table of the remaining up to 32. Since we don't have more than 60, it probably will have only 2 parts. That's what it does here. So the trend data, it doesn't split it. It makes a table inside the table. That's why I don't want to get into that today. We'll get to that in the future, okay? Moreover, it has another thing. It's shuffling the data, okay? In this case, it's okay. We will study in the future the shuffling is not always the right way to do things. Okay. In fact, in this case, you can get better result if you don't shuffle. Okay, but I won't get into that this time. This time, we just want to learn how we do multiple regression. And there's so much, and we're already covering how you prepare an object in AI, which is wonderful. Those stuff will repeat themselves. So that's why I'm spending a little time on that. Okay. Beautiful. We finally have the trained data. Pay attention, I'm not doing it for the testing. There's a reason. Okay. I'm doing only this, bringing it into batches. That's what I call it. That's why it's called batch, if you notice here. Okay, there's a function called batch. And usually you keep 32 or 64 or 128, depending on the size of the data. Here the size is, the data is so small, it won't make much difference anyway. It's a very small database. But usually you'll do at least 32, okay? Wouldn't happen anything if I didn't do those 2 lines, by the way. Nothing would have happened, okay? But the only reason I would have to change the shape of the data, topic that I said I would cover some other time. So the batching is already doing it automatically for you. But that's, again, another topic we'll deal in the future. It's a beautiful topic as well. All right, beautiful. We finally got the data. That's what this function does. Who caused this data? Remember? Who caused the data? The train. If you remember, here we go. The end result of the get data is getting those 2. Let me just summarize it. Eventually, you're getting the data nicely organized into these 2 objects. This object, we have this one and the test, if you remember, test data. This one is, we also split this by batches. And if you remember what we defined those 2 objects, we're defining them in the init. And when you define it in the init, you can access it from everywhere in the object. So here it is. That's what here they are empty. But after the get data, this one is ready to work. So think about it. The data now is ready to work. The get model organized the model. I didn't cover it. I'm going to go over that right now. So by the end of the get data, everything is ready to teach the model about regression. So let's look about the get model, which I skipped before. Theoretically, I should have covered the get model. Nothing would have happened if I put the get model even inside the training, but this is the right place to put it, okay? Let's look at the get data. In fact, get model, as we see in the future, will make it more sophisticated because you might have several models and you tell the algorithm, try several of them, okay? We'll get there. For now, this is a good one to study the structure. Let's look at the get model. What do we do in the get model? Okay, what do we get in the get model? This is the simplest model you can think about, okay? Pay attention that Python have done a lot of work for us, okay? And there is a library called TensorFlow. This is a library in Python written by Google, 2015, almost 10 years. Wow, it was a big news when it came out. It's called TensorFlow. It's a piece of art, really beautiful. By the way, the original one was 2015. Now it's enhanced big time. In 2001, there was version 2, and now there is already version 3, if I remember. It's beautiful. It's amazingly beautiful. There's other libraries. As we go along, we learn. TensorFlow now included the Keresa as another library, which we'll talk about. By the way, you can tell that I'm using the model from Keresa. I really didn't have to do it this way because TensorFlow now embedded inside the Keresa. Again, I won't get into that right now. But now we're going to use from TensorFlow will run the algorithm. They're really kind of going together very well. This library makes a model that we can create, okay? So if we go into, this is the model we create first, a model. How do we create a model? By the way, I don't really know if I used it here. I'm gonna remind myself. Where is it? Get model, here we go. By the way, you can tell. Here we go. In fact, I did it. I really didn't need that model to use that there. I know why I used it for. This one is not really using this model. If you can notice, I'm really using it from TensorFlow has also arrays and it has models. Okay. So I'm not really using this model here. I'm using it to save it to the hard disk. Later on, I think that's why I'm using it there. I'm really using the TensorFlow, the keras built inside the TensorFlow. Theoretically, I don't really need this one, theoretically, but it's okay. If you can tell, I'm using load model, and we'll talk about it later on some other time. And we have also save model, which is also of keras models. But TensorFlow itself has the keras, and this one is more convenient, but that's detail. The important things, I'm using TensorFlow, the keras from TensorFlow to create a model. What is the model going to do? It is going to find the link between those 4 variables to the GDP. That's the objective. So how is the model structured? We start by defining a sequence. This is beautiful because it saves so much time. I remember the TensorFlow 1. It was a nightmare. Now it's so clean. You define a sequence. That means this model has several layers. And this case is such a simple one. You know, when you study regression analysis and statistics, you spend a whole semester. And here, believe it or not, it becomes to be just one line. Okay? You make a sequence and you adding to the model, to the sequence. The model is really the sequence of the model. You can think about it. And then you just add a layer. And this layer called dense. Forget about that name. That's okay. I will cover it many times in the future. What it says is, I'm going to give you 4 columns. That's the input shape. 4 columns going to be data. You have 4 variables. Export, you'll have education, high-tech variables, all of those one. And I want you to find the link. I want you to find the link to the GDP. That's why eventually you'll have one. You'll have 1 output and 4 input. That's all what you need to tell him. Now, this one I said I skipped last time. We're going to talk a lot about this activation function. For now, linear means doing nothing. That's really what it means. Okay? So that's all what I need to do. I'm telling him, okay, build a model that has 4 variables inside input and 1 output. And I want you to find the link between them. And the way I want you to find the link, that's called mean square error. You will learn it by heart in the future. Very popular in the way you do that. What am I telling him to do? I'm telling him, find the link between those 4 to this one such that they will be as close as possible to each other. Okay, that's really the best way to say it, not mathematically. And if you remember when we did one variable in the linear regression on the straight line, okay, what we said, we wanted to find the slope and the intercept such that all the point would be as close as to the line. This one is similarly just in 4 dimensions because we have 4 variables here. So we can't even make a picture of it. But this is the same meaning. And by the way, the same function works there too. The only difference in that example was that the input was just 1, but it's exactly the same, by the way. The only difference is that now we have 4 variables. Beautiful. This one I get back to, this is saving it to the hard disk. Okay, it's saving the model to the hard disk. I will get back. I don't want to spend the time on that today. We'll come back to that. This is creating the model. Now we have a model. Combine is basically just telling him how to find which algorithm to use to find the link. And there is optimizing. That's another topic as well. There's many optimizing. This is the most common one, Adam. Okay, I mentioned I said a couple of sentences about it. But again, it's another one and we discover as we go along. For now, I want you to remember we have a function get model. The end of the get model, we have a model that knows what it's supposed to do. It's not doing anything yet. Okay? As we have a model, remember I said a model will have a fit and or transform or predict. And we'll see in a minute how that works. Okay, so get model, which is being called by the init function. See, pay attention, I'm repeating myself a million times for a reason, because it's really hard first time when you hear it. Eventually it will be easy. So we get the get model, now we have the model. If you notice, I define it as none. After this function, the model is not none anymore. This function makes sure that I have the model. Then in the train, I call the get data. Now I have also the data. Where am I? Here we go. Yeah, we call the get data. So we have the data, we have the model. Next is the feed. You see that? The feed without transform, what it does is learning the connections. The truth of the matter is learning all those 4 parameters in a regression plus the intercept. That's what it does with the data. Okay, pay attention. You can see here batch size 32. Remember when I split the data? I did 32. I took the training X and training Y and I split it to batches. Okay, because that's the way this fit, expecting the data to come. That's the way it does. And why does it do it? We'll talk about it in the future. For now, there's one more thing that's called epoch. That's also I will cover in the future. But now just hear those names. They will repeat themselves. In reinforcement learning, we will learn another thing which is different than epoch, called episode. Episode. We'll come back to that as well. Since they're repeating themselves, I rather to repeat myself many times so you start getting to know them. Beautiful. Now, as is feeding the data, I want him to do one more thing. I skipped it last time. If you notice, I push test data. I don't really have to put that one. I can remove that one. I don't really have to have it. But if I put it there, after is learning the connections between those 4 variables to the GDP, it can test how good is this fit is. It can use the test data, which we already prepared for him. And then he's getting all that results and a lot of things. He's making an object called history. And he's putting it for me here. I'm really basically getting all the result right in here. Pay attention, it's so beautiful. One line of code. So simple, and this is so structured that you will see in the future. It's repeating it. We'll do much more sophisticated stuff than this one. But this is a beautiful example to start getting into this field. So we're getting an object, I usually call him history. That's many people do. Now, this one basically summarizing all the parameters he found. He find out how good that fit on the test data. And that's what we're going to spend the time to understand. And if you see here, I'm creating a dictionary here, and I'm basically pulling the data from the history. Okay? I won't tell you how I know that one of them would be a loss and one is validation loss. Usually loss is built-in, validation loss, I kind of created for it, but we'll come back in the future to it, okay? And I'm looping over those 2. In fact, I'm doing it twice. I didn't want to write this function twice. So in fact, if I want to add another one, so I don't have to write, I like compact code when you write it. And I made a special function called can conversion history. Basically what it does, and you will see in a minute, we'll get the data from this object, okay? And we'll organize it nicely so I can print it in JavaScript. So those data, okay, that I can print them here, here we have only one. I'll run it again. Let's make it 500. You'll see more data here. Okay, I'll run it again. So you see more data here, right here. In the test, I didn't change the scaling. No, I did change. Okay, that should be fine. Anyway, I'm basically taking the results and prepare them to send them to JavaScript. That's all what I'm doing here, really. That's the purpose of the rest of the code. Basically, we finished. But when you finish, you want to present it to the user. because you got the result. You don't want just to print it here because the user doesn't see the pie chart. You want to see it's like a screen like this one. You see, this is much more. By the way, the scaling, I didn't really change the scaling here. How come? I thought I did. This one should, okay. Maybe I didn't. I thought I did. Okay. In Uganda, the numbers are low, so you can't really see them here. Let me use a different country. Let me do the US. But I thought that I fixed it already. So you see also for Uganda would be okay. Anyway. So the purpose of the rest of the code is just get the data to show it to me. So for example, you saw we have the model, okay? The model, we said it's made of layers, if you remember. And we said we had only one. If you know in Python, every list of something, they're always starting from 0. Model has layers. If you remember when we did the get model, and we had a sequence, and we had a layer, we had one layer here, it's the 0 layer, okay? If I want to get the result that he found, I can get to it. So model.layers, basically, where is it? Where am I? Yeah, here we go. This one, basically, he holds all the 4 parameters I'm looking for them. And he has a special function called get weights. We call them weights. Those parameters is looking. So I get them. By the way, all what I did here is just make sure I can send them to the Python so it can transfer. Otherwise, you get an error. Okay, make them a list of Python because this is the NumPy. It's really a structure of TensorFlow variables, but it's already that important. The bottom line is I'm getting the weights. I get bias, by the way, is the intercept. Okay, and there's only one intercept here. So I'm getting that one, I'm scaling them, and then I'm just basically. Now this is good. This is another one. Remember that I told you model, we use transform or predict. I'm not transforming data here. I taught the model got those weight, got the biases. What does it really mean? Let me explain that. If you see, you really found those parameters. This is the bias, by the way. This is the intercept. It found those 4, 1, 2, 3, and 4. So I'm getting it like an equation. If I know the export, the education, the natural resources, I can plug the data there and I can make a prediction. Let's say a country invested a lot of money in developing the high tech in the country. Well, based on this equation, it means, well, that will increase the income of the country. Now, somebody can say, well, by how much it will increase the GDP if the investment would be $1 billion? You can say almost more than $750 million, the income will go up. That's a beautiful. Okay, so you say, okay, let's keep investing in high tech. Fair enough. If I have a lot of natural resources, oil, water, is that increase the income of the country? Definitely. I get here 0.82. Is education, believe it or not, the education is not right. By the way, those numbers, I'm almost sure that if I churn it more, let me churn it more. Those numbers not necessarily right, because I didn't churn it enough. Okay, I can tell it didn't really reach the 0 yet. I will run it for 1,000, more than 1,000. It will take a little time and you will see. Okay, but the idea is if I have those 4 data, I can predict what the GDP is. Now, if you remember, that's very important, we split the data to 80% and 20%. So what we're going to do now, we use the 20%, use the data of the export, education, natural resources, high tech, of the test, and try to predict how much the GDP, according to this equation, supposed to be. Okay? And after I get that result, I want to compare to the real one. Okay, by the way, I wasn't wrong. As I said, this number is probably none. It's not much different than zero. So this one really doesn't affect much. Okay, but really natural resources is very important and high tech is very important. Okay, but you know, education, this sign doesn't make sense to me. It couldn't be negative. Doesn't make sense to me. I need to check the analysis or maybe train it for 5,000 and then I will know better. But anyway, even now, after I do the prediction, I want to compare it to the real one. So this one, take the data of the X, predict how much the GDP is supposed to be based on this model. And then when I take this prediction, I want to compare it to the real one. And then I know how good is this model is. And that's what we're doing here. This one I will go next time, by the way. I will go over that next time. Basically, in the end, I'm comparing, I'm taking the prediction, and I'm taking the original one and sending it back to myself. Here we go. I have the prediction. This is basically this one. I just call it P. I just rounded the numbers. I call it P, so it'll be elegant. And the A is the actual data. And then I'm getting the weight, and I'm getting the bias, and sending it to JavaScript. How do I know that I'm not lying to you? Very simple. We can look at the JavaScript and see how the data come there. Let's see. Okay, it finished 1500. Yeah, it comes to the JavaScript. What is the JavaScript? Let's do it again. Let's refresh. And I didn't log in. What happened here? I'm not logged in. I think I'm not logged in correctly. Bear with me a second. Yeah, I'm not logged in. Apollo was testing. Okay, I'm logged in the right way. We go to here, and let me go into the regression. And now I can see the JavaScript model. Let me go here. This one is getting the data from the Python. That should be NN data. And here we go. This function calling Python returning the data right into here. I will show it to you. Okay. I won't run it too many training. I will just use the 50, so I will go fast. At least 50, so I can see the actual. I will just use another one so we don't screw it up. Okay. And we do regression. It's going to here. Let's click on it. And you will see now when you get back, you'll see the data. Okay. So you saw the whole nice flow. Okay. We'll finish it. Here we go. We're getting the data. You see the matrices of the loss. We'll get the loss validation. We're getting all the data. That's what we're getting from Python. So this one, all this data, which is the predictions versus the actual, the weight of the regression, the bias of the regression, I'm sending it back. This is going back. He knows how to do it. That's the beauty. You get it back, send it to, by the way, this is not the one that's sending it. This one is just the training and is returning it back to the object, to this object that it's communicating. This object we said is communicating to JavaScript. So after you call this training WB, this function getting the result, pay attention. We're calling the train of that object, of the AI object. We're getting the result, which is all the stuff I showed you. And this one goes back. This one is returning it to JavaScript. This is the one that returned to JavaScript. Now JavaScript get it. And here we go. And what do I do now? I basically take this data and use now JavaScript, not Python. And I know how to communicate to this chart and this chart, make a nice chart. I change, you know what it says result will show here is making sure to create the function and present it to the user. JavaScript is communications to the user. The user is the one that want to see the result. Okay. So now if I will do okay here, I will do okay. Here we go. We can do that. You can tell that the model is not really good. The prediction is not very good. And I don't really believe this should be a negative. The export should be positive. Okay. So that's why I need to train it more. Okay. In any case, we got the idea. What is this one, by the way? This is very important. This one came from the model. It shows me, if you remember, we had a parameters called epoch. In fact, I'm transferring how many epochs I want him to run. I gave him 50. Now we're starting really learning a little bit, and we spend more next time. How is this algorithm works? Okay, just think about this way. In the first epoch, it says, let's assume we have some parameters here, just randomly. Of course, it's not going to be right. It's just finding randomly. This sentence is the hardest we have taught up to now. And next time we'll spend more time on it. With that, we'll conclude stage number 1 of learning a little bit about neural network that does the work for, but I will start today just saying it at least. Think about it this way. I have an equation. I really don't know what those parameters are. So most likely, if I put the export, education, all of those, it's not going to give me exactly the GDP. That are going to be different. I take that difference, that's my error, okay? So in the beginning, when I'm trying to find the right parameters, my error is very big. Let's ignore the test for now. We just look at that one, the train. So my error is big. I learn from my error, and I said, okay, the error is such and such. Now I want to change those parameters and check it again. So, but how do I change those parameters? Don't just go and randomly find other one until I find the right one. In mathematics, okay, we'll talk about it next time. In mathematics, you probably have learned, if you studied a little mathematics, if you have a function, you probably have studied derivatives. Did you guys study derivatives in mathematics? Anybody?
Yeah.
Okay.
Yeah.
So you can tell if you have a function with one variable, you know, if you increase the x and the function going up, also the y would go up. You agree? Fair enough? So
Fair.
that's the way a function works. If it's a function that you have x, y is a function of x. If it's a function that goes up, okay, if you increase the x, the y will go up. If it's a function that goes down, when you increase the x, the y will go down, okay? This function of the arrow, okay, this arrow, we want to go into a direction that the arrow will go down because we want to get as close as to the point. So we take the derivatives, and I'll talk about it next time, and we take the derivative and we usually move in the direction of the derivative. Now, one more thing. So if you have a function that goes down and then goes up, on the left side, okay, the derivative will be negative because it's going down, and the right side, because it's going up, the derivative will be positive. So if I'm on the right side, I will go to the left. If I'm on the left side, I'll go to the right. And that's what we'll do next time. I'll spend a little time. It gets very complex, but you really don't have to know it. It's nice at least to hear it once, to know that it's very sophisticated. That's why AI is very sophisticated. And what it does is start with the first time, it doesn't really know much about those parameters as it's trying to minimize the error. And then it does again and again and again until it really gets close. And the method he's using is with these derivatives. And that's so you're repeating until it gets good. Say if I do 500, if you say I will do 500 epochs and I run it, you will see that is, we call it a loss function. The error, it's like bad things. We want a minimum loss, minimum errors, minimum difference. And we're minimizing that function. That function has one play. Here we go. It's just stepping again. But see how it's beautiful. It goes down, down, down. As the more epoch I have, it gets very close. Still have error. That's why I need to train it with more epochs. And this is really the lower it gets, then you know you got the right answers. Okay. Moreover, the model, when I'm predicting the test element, they're getting closer. It's getting close to a 45-degree because the actual and the predict, they're getting close. They're not really good at it. I wish it's getting better, but it's much better than it was before. By the way, just for fun, I do it 2000. You will see that the prediction that will continue going down. Take a little few seconds more. Okay, you will see this one will continue going down. You will see now it's 0.37. You will see when I get here 2000, you will see then the error or the loss, as we call it, will be much lower. And the prediction will be even closer to the actual. There will never be perfect. It will never be perfect prediction, but we'll get as close as possible. And that's really, we went from A to Z of AI process. We're utilizing something that you can learn in statistics. And here, eventually, it's much nicer. You know, I went over all it. It's all new for you. But as you get into it, you will see this is really getting easier. Okay? So now it's the hardest stage, okay, that you are in this training. You will see it will get easier and easier, even if we do even more sophisticated one, but it will get easier. Here we go. And you see, by the way, you see those dots are closer to 45-degree. And you see the arrow went down, still going down, as you can tell. And I wasn't wrong, by the way. You can tell that this one is getting close to zero. The expert, this is getting, it was big negative. It will get positive. I'm sure that if I continue, natural resources, it's very positive and it's very stable already, you can tell. And high tech is definitely positive. So those two you already know, they're very important to make a country richer or poor. That's really the objective. Education is most likely, it's, you know, this one is already taking the effect of education, okay? Because high-tech investment, it's really close to education in high-tech. We can even put a variable of education in high-tech, and then we can see which one is more important. So getting this negative, it's a reflection of the fact that this one is positive. And this one, probably, if I would train it for 5,000, this one getting even smaller, which means it's already education by itself. Okay, after I already know the effect of high tech, the regular education don't really have much effect, but high tech investment or high tech education, much more. As an economist, it makes a lot of sense. For us as a technical people, pay attention. This is really much, much smaller. It was 0.037, 0.011 now. So it's really got much, much better. And that's really the AI algorithm building. And we will follow it in a much more sophisticated. We will do next time. We will do also multi-layer perceptron. We'll get into, let me just introduce, and then we split here. You can, as you notice, I'm adding a lot of more stuff. We'll come to that, okay? Well, before we get into this one, we do it, this will really jump into a beautiful algorithm, but we'll do it in a simpler way, multi-layers, that's for numbers. Pay attention that in this example, where's the regression that I did? Gosh. Yeah, this one, okay? Isn't it? No, this is the images. Where did I do the regression? I always forget. I have this one. Where did we go last time? Do you remember, guys? No, this one, yeah. Okay. This one, we had only one layer, just a regular regression. Believe it or not, to move to much more sophisticated. People doing a PhD used to make, just to make it more multi-layers. You don't have to get into it. And we talk about this one. We will try to teach the algorithm to read a picture. Somebody write, let's say, the number 5. Okay, I want to teach the computer. When he sees a picture like that, he will tell me this is 5. He says this 0, he will tell me this is 0. Or this is 4, he will tell me this is 4. I will teach the computer, and then it will be able to predict it. We'll do it 2 ways, okay? One simple way is multi-layer. It's like we have 1 layer, we'll put more layers, and we'll talk about it next time. That would be one method, okay? And then in the future, we'll do the same things with convolution. This is a very advanced topic, extremely advanced topic. I might give it to you as an exercise. It looks, wow, scary. You will believe it or not, you can do it, okay? I will show you how I'll use convolution in images. And then you use the same logic to other things. By the way, here I can get an image of somebody. I think this is the way it works. I always forget. Where is it? Here we go. We'll see images, and then I will try to find out that this is really a shirt, this is a pants or trouser, or this is a pullover. I will give him different images, and I want the computer to tell me to recognize it, okay? And that's a convolution. It's a very advanced topic, but we'll go step by step. We'll utilize neural network, okay? But instead of just having 1 layer, we'll use several layers. And then we're now really getting into the AI, we're finally getting there. Okay, guys, I'm sorry I was late today. My apology. I just really got confused with the time. If you have questions, please feel free to ask. You're more than welcome.